I'm Mr. Estrada, and I am going to get you prepped for the upcoming Geometry Common Core Regents. So let's get to it. Which object is formed when right triangle RST shown below is rotated around leg RS? To help you with this, I found the little animation from mathisfun.com. You got a right triangle here, and we're going to rotate it around this line, and when we rotate it, what three-dimensional object do we get? So take a look. See how it's rotated. It goes around, and it's going to make a cone. So the answer to number 1 is a cone. Number 2 says the vertices of triangle JKL have coordinates JK and L, under which transformation is the image of triangle J prime, K prime, L prime not congruent to triangle JKL. So we're looking for not congruent. So what you want to do with this question is look at each of the choices and just eliminate the ones that do not match the criteria. So looking at choice 1, it says a translation of 2 units to the right and 2 units down. That will produce a congruent image. Choice 2 has a rotation. Rotations also produce congruent images. And choice 3 has a reflection that will also produce a congruent image. And choice 4 will be the answer. The only transformation that can possibly change the size or the length of an image is a dilation. So that's why the answer is choice 4 here. Also, just so you know, transformations that preserve, that means keep, the size of an image, like a reflection, rotation, and translation, are also called rigid motions. So these guys here that keep the distance, we call these rigid motions. So if it keeps the distance, it is a rigid motion, like choice 1, choice 2, and choice 3. All right, number 3, the center of circle Q has coordinates 3, -2. If circle Q passes through R, 7, 1, what is the length of the diameter? So here's the approach I'm going to take here. I'm going to plot the points. Some of you are thinking, why doesn't he just use the distance formula? Yeah, you could do that, but I'm going to take a different approach here. I'm going to plot the 2 points, and I'll just go ahead and sketch the circle, right? The center is at Q, and it says that the circle passes through point R, and they want the diameter. So as you could see, QR is the radius. So what I'm going to do is I'm going to find the radius QR and then multiply it by 2 to get the diameter. And here's how I'm going to find the radius. I'm going to actually form a right triangle, and I'm going to make it so that QR is the hypotenuse. And if you count the legs of the right triangle I just formed, do you see the right triangle? This is the 90-degree angle here. So if you count the lengths of the legs, we're going to get 3 here, and we're going to get 4 here. So if you use the Pythagorean theorem, you will see that QR comes out to 5, right? So if the radius is 5, then that means the diameter is 10. Let's go to number 4. It says, in the diagram below, congruent figures 1, 2, and 3 are drawn. Which sequence of transformations maps figure 1 onto figure 2 and then onto figure 3? So what I'm gonna do for this one is I'm going to first analyze the figure 1 and figure 2. And as you could see, we go from figure 1 to figure 2 by translating, right? This figure, we just slid it to the right, and then we slid it up to get figure 2. So then that eliminates choice 1, that eliminates choice 2, because we started with a translation. And then after the translation, the only way we can get from figure 2 to figure 3 is by a rotation. So the answer is choice 4. Number 5. So I'm not going to read it just to save some time here. We have a right triangle, and they would like us to find the height of the tree. So I'm going to go ahead and label that X. And what are we told? We are given an angle of elevation of 34 degrees, and that it says the point 20 feet from the base of the tree, and they're talking about this point. So we know that this is 20. So this is a trigonometry type question, and what you want to do is recall SOHCAHTOA, and then SOHCAHTOA is just a nice way to remember the formulas for the different trig ratios. And the appropriate trig ratio here would be tangent, and I'll show you why. Because the height of the tree is opposite from the reference angle, and the 20 is adjacent. So it is tangent that uses the opposite and the adjacent side. So I'm going to go ahead and write the tan of theta. I'm going to write the formula first. Theta means the angle. So the tan of theta is equal to the opposite over the adjacent. And then just go ahead and substitute. We get the tan of 34 is equal to x over 20. And we're going to go ahead and cross multiply. We could put this over 1. We get x equals the tan of 34 degrees times 20. And let's pull out the calculator, see what that works out to. All right, so I got the calculator. Make sure that when you're doing these problems that your calculator is in degree mode. Very, very important. So we're going to do the tan at 34. Whoops. So we're going to do the tan of 34, and we're going to multiply that by 20. And we get approximately 13.5 to the nearest tenth, right? So we just cross multiplied here. X times 1 is x, and then the tan at 34 times 20. And then you could just write tan at 34 times 20 on a calculator. So the answer is choice number 3. Okay, next question. Which figure can have the same cross section? So a cross section, think of it as a slice. And it says which figure can have the same cross section or the same slice as a sphere. So let's just take a look at a sphere. So whichever way you slice a sphere, you're going to get a circle, right? Just one slice. So if you slice left to right, you get a circle. If you slice diagonally, you get a circle. You get circles of different sizes, but you get circles. And the question has to do with which one of these choices will have the same cross section as a sphere, or which one of these choices will have a cross section which is a circle, and that's obviously going to be choice number 2, right? If we slice this way, parallel to the base, we're going to get a circle. Number 7, this is a total weight question, and what you essentially have to do to find the total weight of the object is you have to multiply the density by the volume. So let me give you a little tip about how to find the density, because sometimes they'll even use the word weight to describe the density, and that's okay. But you know what really gives away the density is the units. So if you look here, it says the container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. Now, what gives it away that's the density is the per cubic foot. So you know you're dealing with density when you're dealing with like pounds, grams, whatever, some weight over cubic units. So that's how you know that 0.25 represents the density. So I'm just going to write over here D equals 0.25. And then the volume is something we're going to have to find in this case. It says we have a right rectangular prism with a length of 12 and a width of 8.5 and a height of 4. So then the volume is going to be equal to 12 times 8.5 times 4. And what's that going to be? 12 times 4 is 48. So we get 48 times 8.5. I'll just do that on the calculator. That is 408. So then that's the volume. That's the density, so then we have to do 0.25 times 408, and we're going to get our answer. 0.25 times 408 is 102. Okay, number 8. It says, in the diagram of circle A, shown below, chords CD and EF intersect at G. And chords CE and FD are drawn. Which statement is not always true? So before I even begin the process of elimination, let me point something out here. Anytime you see a drawing like this, you're going to have similar triangles. And I'm going to show you why these triangles are similar, triangles CEG and FDG. We have vertical angles here, and I'm going to say that angle C is congruent to angle F. Now, why is that? If you recall, if you had me as a teacher, we talked about inscribed angles. And if you look at angle C is an inscribed angle, and it's supposed to be half of the intercepted arc DE, right? Angle C is equal to half of the arc ED. Well, guess what? Look at angle F. It intercepts the same arc. So angle F is also half of the arc ED. So you can actually conclude that C is equal to F. Now, if that's the case, then you have two pairs of corresponding congruent angles. That means the triangles are similar by the angle theorem. So we know choice 4 is true. We're looking for the one that's not always true. So we know choice 4 is true. These two triangles are similar. Now, if they're similar, then we have to see if this proportion is true, right? That's what this is. This is a proportion. And all we're really going to look for is to see if the sides and the proportions match up with what we have in the figure. So look at what it says. It says CE over EG. So CE over EG is equal to FD over DG. If you're still having trouble with following that on the figure, you can also look at the similarity statement. CE over EG is equal to FD over DG. This is true. All right, look at what it says next. It says angle CEG, so this angle here, is congruent to angle FDG. Yeah, that's going to be true. And for the same reason that angle C was equal to angle F, remember how we said that it has to do with the intercepted arcs? Let's take a look at that again for angle E and angle D. Angle E is half of the arc CF, and so is angle D. And so obviously by process of elimination, choice 1 is the answer. Number 9, which equation represents a line that's perpendicular to the line 2x minus y equals 7. So what we will do is we're going to go ahead and solve for y. We get negative y equals negative 2x plus 7. And we're going to divide everything by negative 1 to get rid of this negative here. And we get y equals 2x minus 7. We want a perpendicular, so the slope of the original line, let me just write the word slope. Sometimes the M confuses people. The slope of line 1, let's call it, is 2 over 1. What must be the slope of line 2, which is perpendicular, right? It's perpendicular. Well, it must be negative 1 over 2. You're supposed to take this flip it and change the sign, and choice 1 is the only choice that has a slope of -1/2. Number 10, which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? Now, this is a question you could answer with a formula. 360 divided by n will give you the minimum rotation for a regular polygon to carry onto itself. So if we apply this formula to each of the choices, n, by the way, in the formula stands for the number of sides, we're looking for the one that renders 45. So let's start with choice 1. An octagon has 8 sides, so we're going to do 360 divided by 8. And 360 divided by 8 actually is 45 degrees, so choice 1 is the answer. But also, to show you what it means by carry onto itself, I have an octagon here. And you could see that the central angle here, let's call it, is 45 degrees. And what I'm going to go ahead and do is I'm just going to go ahead and rotate this thing 45 degrees for you to show you that it will carry onto itself. So I'm going to rotate 45 degrees, and that means half of 90. So that should be 45 degrees right about there. So you see that the figure carries onto itself. All right, next one, number 11. So what I like to do with these questions, I have a strategy, which is I like to break up the triangles and then make a proportion. So that could be a little lengthy. Some people may not like that, but I like to do it. It gets me the answer, and it always works. So we have one triangle here, AEB, with sides of 9 and 9.2. And then we have the big triangle, triangle ADC. And AD is going to be the sum of 9 and 5, which is 14. And then AC, well, we can just call that X, since that's what we're looking for. So our one proportion that you can make, we could say 9 over 14 is equal to 9.2 over X. Remember, the corresponding sides should match in your proportion. So we're going to go ahead and cross multiply. We got 9.2 times 14. Going to need a calculator for that. 9.2 times 14, we get 128.8. 9 times X is 9X. Divide both sides by 9. 128.8 divided by 9, we get approximately 14.3 to the nearest tenth. Number 12, in scaling triangle ABC shown in the diagram below, angle C is 90. Which equation is always true? Now, you know what they're looking for here? They're looking for the cofunctions. And that's going to be sine and cosine. Where is it? Here it is. The sine of A will always be equal to the cosine of B, as long as, this is the important part, as long as A plus B equals 90 degrees. And we know that A plus B equals 90 degrees because A and B are complementary, right? If angle C is 90, A plus B must add up to 90. And so how do you know that sine and cosine are cofunctions? Think about it like this. You have sine and cosine. Tangent and cotangent are also cofunctions. Secant and cosecant. You don't have to worry about, the tangent and cotangent, secant and cosecant. I don't believe that's part of the curriculum. You just have to know sine and cosine are cofunctions. And as long as A and B add up to 90, this will always be true. Okay, number 13. Quadrilateral ABCD has diagonals AC and BD. Which information is not sufficient to prove ABCD is a parallelogram? All right, so in a parallelogram, opposite sides are congruent and parallel. But if you want to prove a parallelogram, you can just prove that the opposite sides are congruent, and that will show that it's a parallelogram. Or you can prove that opposite sides are parallel. That will also demonstrate a parallelogram. So what we're going to do is we're going to go through each of the choices and just eliminate the ones that will not prove a parallelogram. And let's begin with choice 2, just because it's the choice 2 is the easiest one, and then we'll just work our way around it. So I have 4 parallelograms that I drew here to represent each of the choices. So choice 2 says AB is congruent to CD and BC is congruent to AD. Yes, this will prove a parallelogram. It's proving that the opposite sides are congruent. So choice 2 works. Choice 1, look what choice 1 says. AC and BD bisect each other. That's all it says. But if AC and BD bisect each other, then that means that this segment is equal to this segment. And this segment is equal to this segment. And then, of course, I know I have vertical angles here. So then you could see that these 2 triangles are congruent. And if these 2 triangles are congruent, then by CP/CTC, corresponding parts of congruent triangles, we could say AD is going to be congruent to BC. See how I did that there? Right? I knew the triangles are congruent, so then that automatically means the corresponding sides are congruent. And then, obviously, the same can be said about these triangles here, because we know that these angles are congruent since they're vertical, so therefore I know that these sides are also congruent, and then there you go, I just proved this a parallelogram, opposite sides are congruent. So this is actually enough. That is sufficient. Let's look at choice 3. Choice 3 says AB is congruent to CD. Okay. AB is parallel to CD. Now, it doesn't say anything about the sides BC and AD, but maybe I can somehow prove these triangles are congruent by this information I was given. I have to see, because if I could prove these triangles are congruent with this given information, then I know that these sides are going to be congruent. So I don't know. Let me see. Let me go for it and see where it gets me. All right. I'm obviously going to have vertical angles here. Right? We got that. What I'm trying to do is to prove that these triangles are congruent. You'll see why in a second. There is a method to this madness. So I know these are congruent because they're vertical, and then I know that these are also congruent because they're alternate interior. Now, these triangles are going to be congruent by angle, angle, side. You see that? So then that automatically means that this side is equal to this side by CP/CTC. Right? If the triangles are congruent, then the corresponding parts are congruent. Now, where does that get me? Does that get me anywhere? Yeah, it actually does. Watch, there is a method to this, like I've been saying. I'm going to prove to you that this triangle here is congruent to this triangle here. So far, I got this side congruent to this side. I'm also going to get the vertical angles here. And since these triangles are congruent, remember I proved it already, these are also corresponding parts here. So that means these triangles are congruent by side, angle, side. And if those triangles are congruent by side, angle, side, then we know that these sides must be congruent. So this is enough information. Choice 4 is not going to work. Obviously, choice 4 is going to be the answer. I'm going to show you why choice 4 doesn't work. All we get with choice 4 is AB congruent to CD and BC parallel to AD. This does not prove it's a parallelogram. Let me show you why. That information can also fit the criteria for an isosceles trapezoid. Did you know that? Yeah, Could also fit the criteria for an isosceles trapezoid. So it doesn't prove a parallelogram here. I'll show you how it could fit the criteria for an isosceles trapezoid. Let me just go ahead and draw one. Let's call this A, B, C, and D. Now, what did they say? They said that AB is congruent to CD, like in our isosceles trapezoid. And they said that AD was parallel to BC. Look! So it proves an isosceles trapezoid. So we can't say that it's going to prove a parallelogram. So choice 4 is the answer. That's not sufficient. The information here is not sufficient to prove it's a parallelogram. That was a little lengthy. All right, number 14 requires completing the square to find the center and the length of the radius. So here's how I like to do this. Let's bring all the x's together. In this case, we only have an x. And let's bring all the y's together. And let's add a box after the 6y. And let's add a box here as well, right? If I add a box to the left side of the equation, I have to add a box to the right side. If I added 2 boxes on the left side, I have to add 2 boxes on the right side. If this is the first time you're seeing me do this, you should check out the other video on completing the square with circle equations. It's on my website, mrestrada.com. All right, so what goes in the box? What goes in the box is b divided by 2 squared. B is the 6. So 6 divided by 2 is 3. 3 squared is 9. So I got to put 9 here, and I'm going to have to do that on the right side also to preserve the equality of the equation. So I get x squared plus y squared plus 6y plus 9 equals 7 plus 9. Now, this could be factored. I can factor it like this. Y plus 3 times y plus 3. 7 plus 9 is 16. Why y plus 3 times y plus 3? Well, because 3 times 3 is 9, and 3 plus 3 adds up to 6. But then this, I can rewrite it as x squared plus y plus 3 to the second equals 16. So to get the center of the circle, the x-coordinate is going to be 0 because we don't have a term that comes after the x squared. So the x-coordinate is 0. And then the y-coordinate of the center is going to be -3 because we have to change the sign. So we get 0, -3 for the center. And then to get the radius, you have to square root the 16. So we get 0, -3, and a radius of 4. So let's summarize this. You need to get this equation right over here. You need to get it in standard circle equation form, which looks like this. But generally, it looks like x minus h squared plus y minus k squared equals r squared. To get the center, you have to change the signs of the terms that you see here. That's how I got 0, -3. And then to get the radius, you have to take the square root of r squared. Right? That's r squared. So if you want the radius, you have to square root it. All right, number 15. So they want us to determine which statement is true. What I like to do with these questions is I like to, since we got triangle ABC and triangle DEF, I like to just orient them, make sure that they're just facing the same way. It just really helps me, to match the sides. So A matches with D, so I know this is D, this is going to be E, and then this is going to be F. And we are told AB is 9, BC is 15, DE is 6, EF is 10, and it says angle B is congruent to angle E. Which statement is true? Now, before I even start, I know these triangles are similar. Triangle ABC is similar to triangle DEF. How do I know that? I know that they're similar by side, angle, side. Whoops, let me rewrite that. They're similar by side angle side of similarity. So there's a side angle side for congruency, and there's also a side angle side for similarity. And side angle side similarity says if the corresponding sides are proportional, which they are. I'm going to show you in a second that they are. I kind of assumed that they are, but you're right. I should first I should prove that the corresponding sides are proportional. But anyways, I digress. Back to what side angle side similarity says. It says if the corresponding sides are proportional and the included angles and the corresponding included angles are congruent, then the triangles are similar. Now they are proportional. You could see that they're proportional by making a proportion and just cross multiplying and making sure that both sides are equal. 10 times 9 is 90. 15 times 6 is 90. Checks out. So the triangles are similar. Let's look at the other choices. Choice 1 says CAB, that's this angle here, is congruent to angle DEF. And that's not going to be true, right? Angle CAB is equal to angle FDE or EDF, right? Angle A is equal to angle D. So choice 1 is not true. Well, I just realized that the question's asking for the one that's true. Choice 3 is true, so we're actually done with it. You could look at the other choices if you want to see why they're not true. Choice 2 is not true because the corresponding sides don't match. And choice 4 for the same reason. Number 16. If triangle ABC is dilated by a scale factor of 3, which statement is true of the image? When an image is dilated, the lengths of the sides will change in size by the scale factor, but the angles will remain the same. So choice 3 is out of the question because it's saying to multiply the angle by 3. And choice 4 is out of the question. So it's between choice 1 and choice 2. Now it says triangle ABC is dilated, right? So we're going from little triangle ABC to a bigger triangle A prime, B prime, C prime, because you multiplied by a whole number. So what you could see is that choice 1 is not going to be true. Because choice 1 is saying that 3A prime B prime, so 3 of these is equal to 1AB. That's not the case. The other way around it's true, right? That's why let's look at choice 2. Choice 2 says 1B prime C prime, so one of these guys is equal to 3 BCs. Yeah, it takes 3 of these little guys to make one of these. So this is true. Right? It takes 3 little guys, like 3 little BCs, to make one big B prime C prime. Number 17 says to prove that these lines are parallel. So we want to prove ABCD is parallel to EFG. So just to give you a little tip, to prove that 2 lines are parallel, we can show that the alternate interior angles are congruent. All right, that's what they're looking for here. You can also show that the corresponding angles are congruent. That would also prove that the lines are parallel. So, but I would say 99% of the time, they want you to look for alternate interior angles. So let's take a look at these choices. So choice 1 says angle CFG is congruent to angle FCB. Are they alternate interior? Yes, they are. And if we prove they're congruent, then the lines are parallel. Choice 1 is the answer. Okay, we've made it to number 18. Which ratio is equal to the scale factor K of the dilation? All right, so we're looking for the scale factor. Now, there's 2 ways to get the scale factor here. Let me just go ahead and join ECA and EDB. One way to get the scale factor is to get to say EC over EA, right? So it's like you got the side EC over the big side EA. So that's one way to write the scale factor. Or you can similarly do ED over EB. So the answer will be choice 1 because this is not one of the choices. All right, number 19. A gallon of paint will cover approximately 450 square feet. Okay, an artist wants to paint the outside surfaces of a cube measuring 12 feet on each edge. What is the least number of gallons of paint he must buy to paint the cube? All right, so picture a cube. Try to do my best over here to draw one. He wants to paint, it says, the outside surfaces. So in total, that's 6 surfaces, right? Right, we got 1, 2, 3, 4, 5, 6. Yep, that's 6 surfaces, right? There's 6 faces to a cube. And each surface is a square. So if each cube side measures 12 feet, then that means that like the area of one of those squares, just the area of one of those squares is 144, right? The area of a square is the side squared, which is 144, right? That's the area of one square, but we got 6 of them, right? He's got to paint 6 of them. So that's 6 times 144. So the surface area comes out to 144 times 6, because there's 6 sides, right? One square is 144. The area of one square is 144 square feet. And then multiply that by 6, you get 864. Excuse me. Oh boy, so what's it say? A gallon of paint is going to cover approximately 450 square feet. So let's take 864 and divide it by 450 to see how many gallons of paint he needs. 864 divided by 450 is 1.92. So he has to buy 2 of them. Excuse me. He's got to buy 2 gallons of paint because if he buys 1, it's not going to be enough paint, right? And you can't buy like 1.5. You can't buy them. You can't buy gallons of paint in half. Can't do that. So you need to buy 2 of them. And then it also says the least number. So the least number, yeah, I like the way they worded that. The least number of gallons of paint he must buy is 2. He could buy 3 if he wants, but the least amount that he needs is 2. All right, number 20. Which statement is not always true? And so far, we know that AC is perpendicular to CD. So we know that this is 90 degrees. But we should have known that already because you had a tangent and a radius there. Anytime you have a tangent radius relationship, you know that angle is going to be 90 degrees. All right, so we're going to have to go process of elimination here. All right, let's start with choice 2. Choice 2 says angle ABC, that's this guy over here, is congruent to angle ACD. That's the 90-degree angle. That's true. That's always true. Let me tell you why. Angle B is an inscribed angle, and it's going to be half of the arc AEC. And you know that arc AEC is 180 degrees because of that diameter there. So that's true, right? ACD is 90, angle ABC is 90, right? 90 is half of 180. And by the way, anytime you have an inscribed angle that intercepts a diameter like that, that's automatically 90. Look at choice 3. Angle BAC, that's this guy here. Use a different color for that. Let's use a different color. Let's use green. Angle BAC that's this guy here, is congruent to angle DCB. Well, angle DCB is right over here. Is that going to be true? Yes, it will always be true. I'll explain to you why. Angle A, or angle BAC as it's called here, angle BAC, is half of the arc BC, right? It's an inscribed angle. We talked about inscribed angles earlier. And then angle DCB, angle DCB is also half of the arc BC, right? It has, see, if the vertex of the angle is on the circle, like an inscribed angle where the vertex is on the circle, if the vertex is on the circle, that angle is half of the arc that it intercepts. So this is true. Choice 4. I'm going to have to start erasing some stuff here. Choice 4 says angle CBA, that was our 90-degree angle from earlier, is congruent to angle AEC. Yeah, AEC is also 90. It's an inscribed angle, and it intercepts the diameter, right? So that's true. So by process of elimination, choice 1 is the answer. All right, we got similar triangles. We are told that here. It says AC is 12, DC is 7, and DE is 5. The perimeter of ABC is 30. So I'm going to write P equals 30. Solve for the perimeter of triangle DEC. So you should know, all right, now hear me when I say this to you because I don't feel like writing it. So hear me. You should know that the corresponding sides and the perimeters of similar figures are proportional. Okay, get that in your head. So we got to make a proportion involving the corresponding sides and the perimeters. Now be very careful here because what they did is the triangles, the sides are not matching up the way they should. So I'm going to look at this statement here, the similarity statement, to help guide me as to what are the corresponding sides. So you could see that AC, right, AC is supposed to match with DC. So that means AC matches with DC. And then, of course, the perimeters are going to match with themselves as well. So my proportion, I'm going to write it down for you first. It's going to be AC over the perimeter is equal to DC over the perimeter. So the proportion is going to be 12 over 30 equals 7 over x. Cross multiply, you get 210 equals 12x. It says equals. Divide both sides by 12. What do we get for x? The perimeter we're looking for. Need a calculator. 210 divided by 12. We get 17.5. All right, number 22. So we're looking at dilating lines centered at the origin. So here's the deal. When you dilate a line centered and the center's at the origin, that's the important part, you only multiply the y-intercept by k, which is the scale factor. So the new line will actually have the same slope as the original line, right? Because you're only multiplying b by k. Right, so you're going to have your original line, which is going to be y equals mx plus b, and then the new line is going to be y prime equals mx plus b times k, right? Because you're only multiplying b by the scale factor. So let's tackle this question with that knowledge. All right, we started off with line 3y equals negative 2x plus 8. Let's put it in y equals form. We get y equals negative 2/3 x plus 8 over 3. Now look, if you're making a dilation, if you're dilating this, making a dilation, sorry, if you're going to dilate this by some scale factor, the new line, it's going to have the same slope as the original one. Right? The only thing that's going to change is going to be the y-intercept. It's going to be 8/3 times k, whatever that is. But it's going to have the same slope. So to find our answer, let's look for the line that has a slope of -2/3. Yeah, I know it's going to be tedious to put all these choices in y equals form, but maybe we can eliminate some choices. We can eliminate choice 3 and 4 off the bat, because moving the 3 this way, it's going to give us -3, and then you're going to divide by 2, so that's not going to work. So it's between choice 1 and choice 2. And I'm going to go ahead and say the answer is choice 1. I'm going to tell you why. When you put it in y equals mx plus b form, you're going to get 3y equals -2x plus 5, and then you got to divide by 3. So you're going to get that slope you're looking for of -2/3. All right, number 23. Find the value of x. All right, so it says that a circle with a radius of 5 was divided into 24 congruent sectors. So the radius is 5. Look, there's a lot of stuff going on in this picture. And, you know, if you could learn how to just fade, like all that extra stuff that you don't need, you'll be all right with this question. You'll be all right with this test. They want the value of x. Now, look, here's my approach to this. If you look at what x is half of the circumference. How do I know that? How do I know x is half of the circumference? So circumference is like the perimeter of the circle, right? So I'm referring to this, right? That's your circumference. It's the distance around the circle. That's supposed to be a perfect circle. And if you look at x is half of the circumference. Take a look, right? Because they broke this up. And then they rearranged the pieces, and then they put them together like that. X is half of the circumference. So this problem is really just saying find half of the circumference. Well, the circumference is pi times the diameter. Half of the circumference means we're just going to have to do pi times the diameter divided by 2, right? Because we want half the circumference. So then that's going to be approximately 5 pi. 5 pi works. It's going to be 5 pi, excuse me. 5 pi works out to what? 5 times 3.141592, blah, 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 blah. It's 15.7, so the answer is choice 2. Number 24. Which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? Got to use process of elimination here. So we got to look at each of the choices. It says AB congruent to DE and BC congruent to EF. That's not enough. That's side-side. Side-side is not going to prove that the triangles are congruent. Next one. Says angle D is congruent to angle A. Basically, it's just saying that the corresponding angles are congruent. Does that mean that the triangles are congruent if the corresponding angles are congruent? Absolutely not. That just proves that they're similar, but it doesn't prove that the triangles are congruent. So choice 1 is not the answer. Choice 2 is not the answer. Choice 3 says there's a sequence of rigid motions that maps AB onto DE. Okay, so then that means AB is going to be equal to DE. BC onto EF. And AC onto DF. That will work. That is side, side, side. Choice 3 is the answer. Moving on. 25. All right, so we finally got to these part 2 questions. What do they want us to construct? Construct an inscribed square. All right, so to make an inscribed square, you have to draw the diameter. So you're going to take a ruler and you're going to draw a line that goes through the center of the circle. And then you're going to take your compass and you're going to construct the perpendicular bisector the way I'm showing you how to do it. So you put the compass at one of the endpoints of the diameter, open more than halfway, swing an arc, boom, boom, skiggity. Put the compass, keep the compass setting the same, and move the compass to the other endpoint of the diameter. Swing the arc, swing it like you mean it. Don't be afraid to swing it. Swing that thing. And then what you will do is you're going to connect the points of intersection, and you get your perpendicular bisector. That's not the square, right? They want a square, but we're getting there. To get your square, what you want to do is you want to connect the point of intersection between the perpendicular bisector and the circle, and then that point of intersection between the diameter and the circle, and then you want to just do that again here, and do that again here, and do that again right there, and you get a square inscribed in the circle. Number 26, explain why angle NLO is 40 degrees. All right, so we were told that this is a parallelogram, and since it's a parallelogram, we could say that angle O is also 118 degrees. Opposite angles of a parallelogram are congruent. Then you'll see that we have a triangle here. And since that's a triangle, angle NLO along with angle O and angle ONL must add up to 180 degrees, right? 22 plus 118 plus angle NLO must equal 180 because that's a triangle. And then if you solve this equation, you will see that angle NLO is 40 degrees. So let's write that down. It says angle O is 118 degrees because in a parallelogram, opposite angles are congruent. Angle NLO along with angle O and angle ONL must add up to 180 degrees. That should not be there. Must add up to 180 since they are the angles of a triangle. Since angle O is 118 and angle ONL is 22, angle NLO is 40. Number 27. So we have a segment partition problem here. And let me show you my method to this. So what I like to do is I will plot the points. So we got point A is -6, -5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So that's my point A. And we got point B, 4, 0. 1, 2, 3, 4, 0. That's point B. And that is segment AB. If we connect the 2 points. All right, so here's what they would like. They would like for us to partition the segment in such a way that AP and PB are in a 2:3 ratio. So here's my method. What I will do is I will take the ratio and I'm going to add 2 plus 3 and I'm going to get 5. Now, with that 5, well, let me just do it and then I'll show you. I'll explain it as I do it, right? So 2 plus 3 is 5. And what you're going to do now is you're going to count the vertical distance and the horizontal distance. So the vertical distance is 1, 2, 3, 4, 5. All right, so I'm just going to write vertical over horizontal. So we get the vertical distance is 5, the horizontal distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The horizontal distance is 10. All right, so remember that 5 that we got by adding the numbers that make up the 2:3 ratio? This number here? Just divide the vertical and the horizontal change by that. And you get 1/2. Right now, take that 1 over 2 and then just go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And in doing that, what you actually just did is you broke up the segment AB into 5 equal segments, right? You got 5 equal pieces here. 1, 2, 3, 4, 5. And since they want a 2 to 3 ratio, just count 2 segments, 1, 2, boom, right there. That's point P. That breaks up segment AB into a 2 to 3 ratio. So what are the coordinates of point P? They are -2, -3. All right, so here's how I did it. Pay attention, because I'm not going to write it down. Add 2 plus 3, you get 5. Then find the vertical and the horizontal change. And divide that by this number here that you got from adding the ratios. And that's going to give you a rate of change. Then use that rate of change to break up the line segment into whatever this number was. And then just divide it into the ratio that they want you to divide it into. Since it was 2 to 3, you just count 1 segment, 2 segments, right there, that's point P. Number 28, what do they want? The angle of elevation, they want theta. Remember, SOHCAHTOA, right? This is a trig problem. 4.5 is opposite. The ramp is the hypotenuse. Which formula uses the opposite and the hypotenuse? That would be sine. So write it. The sine of theta equals the opposite over the hypotenuse. This can be divided. 4.5 divided by 11.75. And let's go ahead and do that. 4.5 divided by 11.75. You get this. Right? So the sine of theta is equal to that decimal, or you could keep it as a fraction. To get theta, we're going to have to do the opposite of sine on both sides, right? You're going to have to do sine to the -1 right here, and you're going to do sine to the -1 of this guy here. So doing the inverse sine here just is going to cancel out these sines. Right? It's going to cancel out sine, and you'll be left with theta equals inverse sine, so second sine of 4.5 divided by 11.75. And then the answer is approximately 22.5183, but they would like it to the nearest degree, so we're going to say theta equals 23 degrees. Oops, I guess the calculator wasn't there, right? So here's what I did, right? I did second sine and then 4.5 divided by 11.75. That's how I got my answer. Sorry I didn't realize the calculator was off the screen there. In the diagram below of circle O, the area of shaded sector AOC is 12 pi inches squared, and the length of OA is 6 inches. Determine and state the measurement of angle AOC. No problem. Let's find the area of the whole circle. Well, that's pi r squared, so it's going to be pi times 6 squared, which works out to 36 pi. That's the area of the whole circle. That means area of the whole circle. Now look, let's figure out what percentage or what part this sector is out of the whole circle, and we can do that with this formula, part over whole, right? So 12 pi is a part out of the whole. The whole area is 36 pi. So that sector, right, that sector is 12 pi out of 36 pi, which works out to 1/3. So that sector is 1/3 of the whole circle, right? 12 over 36 reduces to 1/3. Now, We want the measurement of angle AOC. Well, angle AOC is a central angle, and it's going to have to be 1/3 of 360. Well, what's 1/3 of 360? That would be 120. So the answer is 120. We could actually, you could simplify this. I could give you a formula for this. Let me erase this to just make some room. You could, so the formula would look like this. The central angle is equal to the area of the sector. So I'm going to write AS over the area of the whole circle times 360 degrees. That's a formula, right? Central angle is equal to the area of the sector over the area of the whole circle times 360. All right, after a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. Explain why triangle ABC is congruent to triangle A prime, B prime, C prime. All right, this question is very, very simple. If it was reflected, so it says, since the transformation performed is a reflection which preserves the distance, triangle ABC will be congruent to triangle A prime, B prime, C prime. A reflection is a rigid motion that preserves distance. All right, so number 31. I hope you know your overlapping similar triangles for this one, because that's what we're going to get. It says that we have a flagpole. So there is my flagpole. And we are looking for the height of this flagpole, so I'm going to label it X. Then it says that this flagpole is casting a shadow that is 16.6 meters long. So just so you know, shadows are on the floor, right? I'm going to just say the sun is over here somewhere. So there's the sun, the shadow is going to be this way, and shadows are on the floor. So that's why I drew a line like this, and I made it 16.6 meters long. All right, then it says Tim is standing at a distance of 12.45 feet from the base of the flagpole. So here's the flagpole, and I'm going to put Tim somewhere over here. There's Tim, happy Tim. And what's it say of it? That's a smiley face. It says that he's 1.65 meters tall, so let's make it 1.65. And they would like for us to solve for X. Oh, forgot one more thing. It says Tim is standing at a distance of 12.45 meters from the flagpole. So the distance from here to Tim is 12.45. Okay, so we got to solve for X. So I'm just going to go ahead and connect this over here. So you could see that what we got going here is we got two similar triangles, right? We got one triangle here, and then we got another triangle here, which is like the whole thing. And we want to solve for the height here. We want to solve for X. Now, if this is 12.45 and the whole thing is 16.6, we could figure out what this piece is. That's going to be 16.6 take away 12.45. So 16 take away 12 is 4. So, and then we got 0.6 take away 0.45, that's 0.15. So we're going to get 4.15 for this part here. So let's separate the triangles, so that way it makes it easier to see the proportion. So this is 1.65. This is the little triangle made up of Tim and his shadow. So that's 1.65. And this is 4.15. And then we got the whole thing. This is X. And then that shadow there is 16.6. So you could see the proportion here, right? Hopefully you could see it. I'm going to write 16, excuse me, that's not 16, that's 1.65 over 4.15, and I'm going to set that equal to X over 16.6. You got to make sure your corresponding sides match on these proportions. So let's go ahead and cross multiply. We will get 4.15x equals 1.65 times 16.6. Let's get a calculator for that. We get 27.39. Divide both sides by 4.15. So 27.39 divided by 4.15, we get exactly 6.6. So that is our answer. It is to the nearest tenth of a meter. Number 32. It says that GH is equal to IH. So that means this triangle is isosceles, right? These two angles are going to be equal. It says EGB is 50. So let's make EGB 50. DIG is 115 degrees. Where's DIG? Here you are. And explain why AB is parallel to CD. Now, I said this before. If you want to prove that two lines are parallel, one way to do it is to demonstrate that alternate interior angles are congruent. So let's go ahead and do that. And I'm going to be looking here. I'm going to be looking at this Z here, and what I want to do is I want to show that this angle here is congruent to this angle here. If these two angles are congruent, then we're going to have equal alternate interior angles, and then that would mean that AB is parallel to CD. So let's go ahead and do that. So 180 take away 115 is going to give us the measurement of this angle right over here. So 180 take away 115 is 65. So we get 65 here. And if that's 65, that means this guy's 165 also, because these two are equal. Now these three angles here have to add up to 180, right? Because the angles that form a line must add up to 180. So we got 65 plus BGI plus 50 equals 180. 65 plus 50 is 115. 180 take away 115 is, what do you know? 65. So it turns out that this is 65 degrees, and then that would mean that AB is parallel to CD because alternate interior angles are congruent. So here's what we're going to write. Angle GIH is 65 since it's supplementary with angle DIG. That's this angle right here. Angle HGI is also 65 because the base angles of an isosceles triangle are congruent, right? These two angles are congruent. They are the base angles of an isosceles triangle. And then we say angle BGI is 65 since angle HGI, angle BGI, and angle EGB are supplementary. That's all the work we did here. That's how we got the 65 there. Therefore, AB is parallel to CD since alternate interior angles are congruent. All right, number 33. Given that the quadrilateral is a parallelogram, prove triangle AED is congruent to triangle CEB. All right, so since this is a parallelogram and I want to prove that this triangle here, AED, is congruent to this triangle here, I will be able to use all the properties of a parallelogram, right? Because I'm told that it's a parallelogram, so I'm going to use that to demonstrate that these two triangles are congruent by one of the postulates. Either side, 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 angle, side, angle, angle, side, angle, side, angle. So I have to use one of those postulates. For me, it's just easier to use side, angle, side. So I'm going to go ahead and use side, angle, side. Since it's a parallelogram, the diagonals of a parallelogram bisect each other. So therefore, AE is congruent to EC and DE is congruent to EB. and then we're going to have vertical angles here. So the triangles are congruent by side angle side. But I actually have to explain that. So here's my explanation. In a parallelogram, diagonals bisect each other, therefore AE is equal to EC and DE is equal to EB. Angle AED is equal to angle CEB since they are vertical angles. Triangle AED is congruent to triangle CEB by side angle side. So there you go. We proved it. And just a little tip on the proofs. What really helps me is to label the diagram with tick marks the way that I did it just here. And then just make sure that everything that has marks is included in your proof. So I did a paragraph proof and I made sure that everything that was marked up is in the proof. You can actually see it right here, right? AE equal to EC, DE equal to EB, and then you see the vertical angles here. You know, it helps to really get yourself organized for the writing of the proof when you label everything. All right, lastly, it says describe a rigid motion that maps triangle AED onto triangle CEB. One thing you could have said is a rotation of 180 degrees about point E. That would have perfectly mapped triangle AED onto CEB. And then you could have also said, I won't write this down, but I'll say it, you could have also reflected triangle AED across point E, and then it would have mapped onto triangle CEB, right? Because when you reflect about that point, point D will reflect where point B is, and point A will reflect where point C is, right? Because reflecting about a point will switch them like that. All right, number 34. What's it say? If the path from the park ranger station to the campground is 0.55 miles, determine and state to the nearest hundredth of a mile the distance between the park ranger station and the lifeguard chair. So the first thing that they want us to solve for is the distance between the park ranger, which is point P, right? It says it right over here, and the lifeguard chair, so that's point L. So they want us to find this. And in order for us to find X, we will have to use the Pythagorean theorem. So let's go ahead and use it. Let's write it down first. A squared plus B squared equals C squared. Remember, in Pythagorean theorem, the hypotenuse must be C. So we get X squared plus 0.25 squared equals 0.55 squared. So we will get X squared plus 0.0625 equals 0.3025, and let's go ahead and solve for X. Minus 0.0625 on both sides. Just use my calculator for that. Minus 0.0625. We get X squared equals 0.24. Let's square root both sides. Square root of 0.24. So we're going to write X equals 0.48. Or you could even say PL equals 0.48. Even better. So PL is 0.48. Okay, so the last one says Gerald believes the distance from the first aid station to the campground is at least 1.5 miles. Is Gerald correct? Justify your answer. So that's asking us to find FC, I'll just call it Y. Why not? Which is the hypotenuse of like the big triangle, right? So that's what we're looking for. Now, some of you have seen me do this before. I'll just real quick, I'll point out to you that we do have three similar right triangles here, right? We got one little one, one medium one, and then just the big right triangle. And what I'm going to go ahead and do is I'm going to separate two of those to help you to see the proportion I'm going to write. So let me take the little one. I'll put it here. And of course, the way I just dragged that out, you can see that this hypotenuse is 0.55 and then this base is 0.25. And now I'm going to also separate the big one, and I'm going to, so here's what I'll do. I have to flip it, so I gotta flip it, and then I have to rotate it so that so that its corresponding sides match with the little one. But the hypotenuse is what we're looking for, so that's y. And then you could see that the base is also 0.55. So one proportion I can write is 0.55 over 0.25 equals y over 0.55. So let's go ahead and cross multiply to solve for y. We're going to get 0.25 y equals 0.55 times 0.55, which is 0.3025. We'll divide both sides by 0.25. And we get y is equal to 1.21. Which means that, what was the original name? FC. So FC is 1.21. All right, so it says Gerald believes the distance from the first aid station to the campground is at least 1.5 miles. Is Gerald correct? Justify your answer. So what we're going to say is Gerald is incorrect because the distance is 1.21 miles, which is less than 1.5. So it's 1.21. This is a mistake here. That should say 1.21. Okay, number 35. The water tower in the picture below is modeled by the two-dimensional figure beside it. The water tower is composed of a hemisphere. By the way, a hemisphere is half of a sphere, a cylinder, and a cone. Let C be the center of the hemisphere, and let D be the center of the base of the cone. All right, so the first question says, if AC is 8.5, they did not label that. Oh, they did label it. Okay, AC is 8.5. BF is 25, it's labeled, and EFD is 47. Determine and state to the nearest cubic foot the volume of the water tower. Now look, here's the deal. To find the volume of the water tower, you're going to have to find the volume of three objects. All right, and I'll tell you what those three objects are right now. You're going to need to find the volume of a cone, because that's what this represents, this two-dimensional figure represents the cone, the volume of a cylinder, and then the volume of a hemisphere, which is half of a sphere. So before I even start, I'm going to write down the formulas for the volume of each of these objects. So the formula for the volume of a cone, the volume for a cylinder. So the volume of the hemisphere, so the hemisphere is half of a sphere. The volume of a regular sphere is just 4/3 pi r cubed. The volume of a hemisphere is half of the sphere, so I just have to take that and divide it by 2. And that's what I'll do. I could simplify 4/3 over 2, but I'll just go ahead and do it this way. All right, so now, to find the volume of the water tower, so the water tower is made up of the three objects, right? The cone, the cylinder, and the hemisphere. I have to find the volume of those three objects and then add it up, and I'll get the volume of the whole water tower. So let's begin with the cone. So there's the formula for the volume of the cone. To find the volume of a cone, you need a radius and a height. Now, the radius is 8.5. Why is it 8.5? I'm glad you asked, and I'll tell you why it is. See, the radius of the hemisphere here is 8.5. Well, this BC is also the radius of the hemisphere, so if that's 8.5, that's 8.5. So now I have to find the height of the cone. They didn't give me the height. I have to go ahead and find it. And you could see that there is a right triangle here, so I can use trig to find that height. And so I'm going to use the tangent ratio because h is opposite of the 47 and 8.5 is adjacent to it. So I'm going to go ahead and write the tan of 47 is equal to h over 8.5, right? Tan of 47 equals opposite over adjacent. Cross multiply and you should get h equals 9.1151. So now I have everything I need to find the volume of the cone. I needed a radius and a height. Now I have those two things. So I'm going to go ahead and write the formula here. So I get cone equals 1/3 pi r squared times the height. It's a 1/3. And when you multiply this out in the calculator, you should get 689.6487. Okay, so that's the volume of the cone, 689.6487. And then now to find, oh, by the way, if you're wondering how to do that on a calculator, I'll just show you real quick. What you want to do is, so you're going to write 1/3 as a division, so parentheses 1 divided by 3, and then times pi. You could just write pi. The calculator knows it's going to multiply by pi. And then parentheses 8.5, close parentheses, squared. And then we got 9.1151. Close that, enter, you get 689.6487 approximately when you round it to 4 decimal places. Okay, then we got to find the volume of the cylinder. So the volume of a cylinder is pi r squared times the height. We have a radius, it's 8.5 of the cylinder, and we have a height. The height is 25 for the cylinder. So let's go ahead and substitute. So it's going to be volume of the cylinder equals pi 8.5 squared. And then after we multiply that out, we should get 5,674.5017. And then you can put it in the calculator similarly to how I did the cone. Just you're not going to write 1/3 in it. Okay, now the volume of the hemisphere. So what I'll do is I'll just find the volume of the hemisphere by doing 4/3 pi. The radius of the hemisphere is 8.5. So 4/3 pi 8.5 cubed. I'll do that first, and then whatever I get, I'll divide it by 2. And then that will give me the volume of the hemisphere. So I'll do it on the calculator. I'll show you how I do it. So I need the 4/3 inside parentheses. So 4/3 pi. Notice that like the fractions, I like to put them inside parentheses. So 4/3 pi 8.5, raise that to the third, 8.5, close the parentheses, raise that to the third, enter, and then we're going to divide that by 2 because we want half of the hemisphere. So we get 1286.2204. 1286.2204. Now, to get our final answer, I know we're still not done, it's a little lengthy. To get the volume of the water tower, we're going to have to add that 1286.2204. We're going to add that to the volume of the cylinder. Also add in the volume of the cone. Yep. Enter. Let's round that to the nearest cubic foot. We get 7,650. That is the answer. Oh boy, yeah, I know, that was long. All right, the next part, yes, there is another part. It says the water tower was constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the tower be filled to 85% of its volume and not exceed the weight limit? So what I'm going to go ahead and do first, I'm going to go ahead and multiply 7,650, which is the total volume, multiply it by 62.4 so that I can get that total weight. When I multiply that out, I'm going to get 477,360 pounds. All right, I'll just write pounds. That's what I get, right? Because it's the volume times the density. Now, what is 85% of this? Right? I have to figure out what's 85% of that. Well, to get 85% of this, I have to do 0.85 times 477,360. And when I do that, I get 405,756 pounds. The question is, the water tower was constructed to hold a maximum of 400,000 pounds. So can we fill it to 85% capacity? The answer is no. We cannot. No, because 85% of 477,360 exceeds 400,000. All right, let's move on to the last one. We've made it to the last one. We made it. It says in the coordinate plane, we got the vertices of a triangle, RST. So let's go ahead and graph the triangle. Okay, there it is. I graphed it. And what we want to do is we want to prove that this is a right triangle. Presumably, the right angle would be here. I just have to prove it. And the way I'm going to do that is I'm going to prove it by finding the slope of TS. And I want to find the slope of SR. And I want these slopes to be negative reciprocals, because if they are, that would mean TS is perpendicular to SR, which would mean that angle S is 90 degrees, which would therefore mean that it is indeed a right triangle. So what is the slope of TS? So slope is just rise over run. So let's go ahead and find that rise over run and simplify it. So it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3, 4, 5, 6. So it goes down 10 over 6, but down 10 over 6 simplifies to down 5 over 3. Right, I just simplified it using 2. Negative 10 divided by 2 is negative 5. 6 divided by 2 is 3. Now, what's the slope of SR? You better hope it's 3/5. Because if it's not, we did something wrong. Right? You want those slopes to be negative reciprocals. So let's see. It goes up 1, 2, 3 over 1, 2, 3, 4, 5. It is 3/5. So here's what we're going to write. Since the slopes of TS and SR are negative reciprocals, TS is perpendicular to SR. Therefore, angle S equals 90 degrees, which means triangle TSR is a right triangle by definition. Okay, lastly, it says, well, actually not lastly, there's another part to this. State the coordinates of point P such that quadrilateral RSTP is a rectangle. So if we want to make a rectangle here, I need to follow the same slope of SR from point T. So you remember the slope of SR was up 3 over 5. So I'm going to do the same thing here. I'm going to go up 1, 2, 3 over 1, 2, 3, 4, 5. So that's going to be my point P. I'm going to connect the points, and hopefully it's going to look like a rectangle. And you could see that indeed it does. Now let's start to think ahead, right? Why would this be a rectangle? Well, we got a 90-degree angle here. We're going to have a 90-degree angle here, as you'll see in a second. These are 90-degree angles, and it is opposite sides are parallel. So it's just good to think ahead. But let's not jump too ahead. Let's answer the question first. It says, state the coordinates of point P such that quadrilateral RSTP is a rectangle. They just want us to state point P. The coordinates of point P are 0, 9, right? 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I get a little paranoid, so I just have to make sure. Okay, now, lastly, we have to prove that that this is indeed a rectangle. That's why I was thinking ahead a little bit. So what would make something a rectangle? Well, it has to be a parallelogram with consecutive 90-degree angles. That would make it a rectangle automatically. So is it a parallelogram? Yes, it is, because the opposite sides are parallel. But I just have to demonstrate that. So let's go ahead and do that. We found the slope of TS already. We found it to be -5/3. And we found the slope of SR to be 3/5. Right? These are slopes, not distances. What's the slope of TP? Well, it's also 3/5. What's the slope of PR? Well, it's also -5/3. So it's a parallelogram because the opposite sides are parallel. So let's go ahead and write that. So it says RSTP is a parallelogram since opposite sides are parallel, right? And the evidence is the slopes as you see them there on the screen. Now we got to prove it's a rectangle. Well, why is it a rectangle? Well, it's a rectangle because we have two consecutive 90-degree angles. So let's go ahead and write that. So it says RSTP is a rectangle because it's a parallelogram with two consecutive right angles. So we are done. I hope this video helps you get prepared for the Regents. Don't forget to subscribe to my channel and like the video. Peace.